So determinants are usually found for matrices which are maybe 2 by 2 or 3 by 3, 4 by 4. These are known as square matrices. So to find the determinant of a 2 by 2 matrix, one thing you need to know is that you have to multiply the major diagonal minus the minor diagonal. So I'm going to show you what we mean by these diagonals and how we can compute for the determinant. Okay, so given the matrix A, one thing you should know is that these values here are in the major diagonal. So this is the major supposed to be J, major diagonal, like that. Then let me use a different color. These values that we have here are in the minor. So that's the minor diagonal, like that. So you need to multiply the major diagonal, then we subtract the minor diagonal. So if you look at this matrix that we have A here, we have B, we have C, we have D. So multiply the major diagonal. So what we have in the major diagonal? In the major diagonal, we have AD, which is AD. So this is the AD that we have here, minus the minor diagonal, which is BC. This is the BC that we have. So determinant can be, we can use the symbol det A to represent the determinant of A is equals to major diagonal. So again, this represents the major diagonal, and this represents the minor diagonal. It can also be written like this with 2 bars, just represent the determinant as well. So we're just going to look at some examples so that you understand what we're talking about. Okay, so we've been given these two matrices, matrix A and matrix B. Then we have to find the determinants for the two matrices. Now remember what we talked about is major diagonal minus minor. So to find the determinant of A, so det A, so what we have in the major diagonal, we have 3 multiplied by 4 minus the minor diagonal, which is 1 multiplied by -3. So this should give us 12 minus -3, like that. And of course, this will give us a 15. So the determinant of matrix A is simply +15. So let's find the determinant of matrix B. Again, major diagonal minus the minor diagonal. So in the major diagonal, we have -4 times 5. Remember that this is the major diagonal. Whatever you have in there is the major diagonal. So minus the minor diagonal, then whatever you have here is the minor diagonal. So that is 7 times 2. So this will give us -20 minus 14. Then what we're going to get will be -34. So the determinant of matrix B is equals to -34. Then there are some questions in which you'll be given the determinant, then you'll be asked to find a certain value within the matrix. Given a question, for example, this one, given that the determinant of a matrix, this is a matrix that we have, is 9, find the value of x. So all we need to do is, we have to say that the determinant, so let's say determinant of this matrix, let's call it A, is given by the major diagonal, which is -1, multiplied by x, minus, remember, major minus minor, so the minor diagonal is 6 times -2, like that. So we want to find the value of x. So to find the value of x, we know that the determinant we've been given, the determinant is 9, so 9 is equals to, so -1 times x, we get -x, like that, minus 6 times -2, get -12. Okay, so this will give us 9 is equals to -x plus 12, like that. So since we're finding the value of x and we want it as a positive, what we can do is just push it to the other side, so it becomes a positive. X is equals to the 12 that we have here. Then this 9 can come to the other side as well to give us a -9, like that, meaning that the value of x is simply equals to 3. So this is how we solve questions on the determinant of a 3 by 3. So let's just go quickly and jump into some examples so that you get the concept. So our first example is this matrix that we have. So Let me just call this matrix A, like that. So to find the determinant of this matrix, we have to break it down in a certain way such that we form smaller matrices, then we can proceed to find the determinant. So what you have to do at this stage is you have to choose a side which you want. You can choose this side, this side, this side, or at the top, it's up to you. But regardless of the side you choose, we're going to have this as a positive value, this as a negative, this as a positive value. So I usually like picking from the top. If you want, you can pick these three values, then you'll see the order of what I'm talking about. So once you do the choosing of the side, always make sure that the first entity is a positive, the second one is a negative, then the third one is a positive as well. Now, what's the meaning of all this? So this is what will happen. We're going to be getting these values that we have here on top, which is 1, negative, 2, and 3. And we're going to be multiplying them with a 2 by 2 that we're going to be forming. This is what I mean. So the first entity that we have is a 1. So we have a 1 here. So after getting that 1, we need to form a 2 by 2 matrix. Now, how do we form that 2 by 2 matrix? So what we're going to do is, if you look at that 1 that we have right here, we are going to get everything except the row in which 1 is in and the column in which 1 is in. So what I mean by that is we're going to get every entity except everything in that column and everything in that row. So the row for that 1 is this one, so we don't need these values. I'll just hide them like that. Then the column for that same value is this one, so we don't need these values. So if you look at what we have, I've formed a 2 by 2 matrix. So let me write it down. 0, 3, 5, and 4. Okay, I remove everything again. Then I go to the next entity. Now the next value, remember, is positive, negative, positive. So I need to put a negative, which is that one on top. Then the value which I have there is negative 2, like that. So now let's form a 2 by 2 matrix. Same procedure. So I'm going to hide its row, its column, like that. Then I'm going to hide its row. Let me just do like that. Okay. So whatever is remaining forms the 2 by 2 we're looking for. And the 2 by 2 which is formed is simply 2, 1, 3, and 4. Of course, you don't need these papers. Once you get the concept, you can just do it just by visualizing. So now the last part, of course, the entity is a 3. So what I'm going to do is I don't need that row and I don't need that column in which 3 is in. Meaning that what I remain with is 2, 1, 0, and 5. Like that. That's it. I'm done with the papers. So now at this point, we are just going to find the determinants of these 2 by 2 matrices and multiply them with these scalars, which are just outside the matrices. So this is what will happen now. So we have 1. So now this is where the part of finding the determinant of a 2 by 2 comes in. In case you don't know, like I said, go in the description. You find the video which the link for the video which shows how to find the determinant of a 2 by 2. But I'll quickly run through it so that you can also understand it here. So the 2 by 2 matrix is found, the determinant of a 2 by 2 is found by multiplying the major diagonal and subtracting the product of the minor diagonal. So in other words, we're saying 0 times 4, which is a 0, minus 5 times 3, which is 15. So negative will give us a positive 2. 4 times 2 is 8, 1 times 3 is 3, like that, plus this 3 here. 5 times 2, that's 10, 1 times 0, that's 0, like that. So that's how we find the determinant of a 2 by 2. Then from there we can proceed by saying this is 1, so I have 1 outside. Inside the bracket we have negative 15 plus 2. 8 minus 3, I've already mentioned the answer, which is a 5. Plus 3, then here we just have, that. So if we proceed with this now, we're going to get negative 15 plus 10 plus 30. So negative 15 plus 10 gives us negative 5 plus 30. So the determinant, remember we're looking at matrix A, is simply equals to 25. So that's how it's done. So don't forget the plus minus plus. Then from there find the determinants of a 2 by 2. You break it down all the way until you get your your 25. So let's look at one more example. So in the next example, I want you to follow it carefully again so that we are on the same page. But before we go to the next one, assuming I did not choose the upper values, which are these ones. Suppose I chose, let me say these ones, plus, minus, plus, like this. Then I'll have 1, this one here, I hide everything, I'll remain with this. I'll have -2, I hide everything, every row, every column, just like that. Otherwise, it's just the same procedure. If you want, you can put them here, you can put them there, you still get the same values. Okay, let's look at the next example. Okay, so here's our example. I'll call this matrix B, since the first one was A. So from here, let's form the smaller matrices, the smaller 2 by 2 matrices. So I'll pick the top part, which is plus, minus, plus, like that. Then let's proceed. So the first value is -5. We have a -5 here. So let's form the 2 by 2. So like I did in the previous example, remember I said you hide the row, you hide the column. So the column for 5 is that one, the row for 5 is that one. The 2 by 2 that is formed is simply -1, 2, -2, 1. Okay, we'll go to the next value. Now remember, the next value has a negative and the value is -5. The 2 by 2 which will be formed, in this case we hide its row and its column. So we have 3, 4, -2, 1, like that. Okay, lastly, the last value is -5 again. So we hide its row and its column, like that. So what do we remain with? The 2 by 2 formed is 3, 4, -1, and 2. Okay, now let's find the determinant of the 2 by 2 matrices. Let's do this. Okay, let's find the determinants of the 2 by 2 matrices. So we have -5 here. -1 times -1, -1 times +1 rather is -1, minus 2 times -2 is -4. We'll have that. Negative will give us a +5. 3 times 1 is a 3. 4 times -2 is -8. Minus 5. 3 times 2 is a 6. 4 times 1 is -4, like that. So we have that. Okay. Then from there, it's just a matter of simplifying what we have in the brackets. So we have -5. This will become -1 plus 4 plus 5. This will become 3 plus 8. And this will become 6 plus 4, like that. Okay, next part will be -5. This will give us a 3 plus 5. This will give us 11 minus 5. This will give us 10. Okay, next part, this will give us -15 plus 55 minus 50, like that. -15 plus 55 should give us a positive 40 minus 50, meaning that our final answer, which is the determinant for B, is simply equals to -10. So that's how we find the determinant of a 3 by 3. How to find the determinant of a 3 by 3 using the diagonal method. So the diagonal method is just another way that is used to find the determinant. Of course, you can use the other method, of which I posted a video. I'll share the link in the description. But this is also another way of finding the determinant. Is it correct? Does it give correct answers? Yes, it does. It's just the same procedure, just a different way of doing things. Okay, so now, given the matrix A, that's our matrix A, then how do we find the determinant using this method? So this is what we do. Let's rewrite matrix A like this. So we have A, D, G, B, E, H, C, F, I. Then let's write the first 2 columns of this matrix. The first 2 columns being A, D, G, which is this one here, B, E, H, like that. So this is all we need. If you want, you can even close it or not. It's up to you. This is all you need. So once you do this now, we're going to look at now the process of multiplying what we have. So we're going to get the first diagonal, the major diagonal. That's why it's known as the diagonal method. So the first major diagonal is formed by these three entities. So this is our first diagonal. The second diagonal will be formed here. And the third diagonal will be formed here. Okay. So these are the three diagonals that we have. Then the next part now, we're going to look at the other three diagonals. So the other three diagonals that we're going to have in this case will be formed here. So the other three will be formed here, like this. The other one will be formed here. The other one will be formed here. So anything that is not part of these diagonals that we've written here, it's not necessary, we won't use them. Letters, numbers like D here and E there, we will not use them. We'll just focus on these diagonals that we have just now. Okay, so now we're going to start the process of multiplying. So everything in this diagonal in red will be positive. Everything must be multiplied but must be positive. In other words, what we're saying is everything here will be A times E times I, positive. The next part is B times F times G, so positive as well. B, F, G, positive. The next positive part will be C, D, and H, like that. So all these are positive. Everything going in this direction is positive. Then everything going in the opposite direction, everything in blue should be negative now. So GEC or CGE, whichever way, should be negative. So we'll say minus CEG minus AFH minus BDI. Looks like a J, sorry. It's supposed to be I, like that. Then that's it. Of course, these will be values. You'll find actual values of these particular matrices. So once you compute this, then you get your determinant. So let's look at an example which has values so that you get the concept clearly. Okay, so here's a practical example. Let's find the determinant of this matrix using the diagonal method. So this will be given as 1, 2, 1, negative 2, 0, 5. We have 3, 3, 4. Now remember, we have to write the two columns like we did in the previous one, of which we have 1, 2, 1, negative 2, 0, 5, like that. Okay, so now having done that, remember we have to maintain the positives and the negatives. So this major diagonal here should be positive, this one here should be positive, and this one here should be positive as well. So let's multiply them. So 1 times 0 times 4, of course that will just give us a 0. So that will be 0 plus negative 2 times 3 is 6 times 1, negative 6. So negative 6. It's a positive as well there. Then lastly we have 3 times 2 times 5. So that should give us positive 30. Okay. So now having multiplied those, let's multiply everything in the minor diagonal now. So everything in the minor diagonal, we have these three here. These three are multiplying. Have these three multiplying. And we have these three multiplying as well. So now remember these ones must be negative. So 1 times 0 times 3, that will give us a negative 0. 5 times 3, 15 times 1, 15, minus 15. Remember these ones are negative. 4 times 2 is 8. 8 times negative 4 is negative 16. So minus negative 16. Like that. So having done that now, let's just compute these values that we have. So negative 6 plus 30 will just give us a 24. Then here we have negative 15. The 0 goes. Here we have a positive 16, like that. So this will reduce to 24 minus 15, we'll simply get a 9. 9 plus 16, like that. Then of course 9 plus 16 will get 25. So assuming this was matrix A, then we just say det A is equal to 25. So this is how this method is used. So the key here is to put the first two columns, rewrite the first two columns, then make sure that the major diagonals is positive and the minor diagonal is negative. Then you have your answer like that. Thank you very much. Looking at how to find the determinant of a 4 by 4 matrix. Now it's very important to know how to find the determinant of a 3 by 3 as well as the determinant of a 2 by 2, because that will help us, or rather that's what we'll be using as we are finding the determinant of a 4 by 4. Okay, so what I want to do is from the first row we need to set up alternative signs like this, and that's what we'll be using as we try to find the determinant. Okay, so using the first row, we're going to be picking the value of the first row, then alternating the sign, then we should be finding the determinants of 3 by 3 matrices. Okay, so let's just go ahead so that you can see what I'm talking about. So if we start with the first value, which is 1, we can have 1. Then after having 1, we need to create a 3 by 3 matrix. Now the 3 by 3 matrix will be formed by every value excluding what we have in the first row, which is for 1, as well as the column. So everything except this column and except this row. So what we have should be 5, 2, 1. We should also have 0, 3, -2, as well as 3, 5, 3. Okay, so the next we have a negative here, so we should say -0, of which 0 will just cancel out with everything. So everything except the first row where 0 is, as well as the second column. So the values that remain will be 2, -1, 2. We should also have 0, 3, -2, as well as 3, 5, 3. Okay, next one is 4. Now 4 should be a positive. So everything except this row for 4 and except this column for 4. So what we should have is 2, -1, 2, then 5, 2, 1, also 3, 5, 3. Okay, then lastly we have -6. Now -6 will multiply with this negative here. Of course, we said the signs are alternating, so to become a positive. So everything except this row and this column, what we should have should be 2, 5, 0, -1, 2, 3, 2, 1, -2. Okay, so we have formed 4 3 by 3 matrices. Now this is where you need to know how to find the determinant of a 3 by 3. So if you go in the description below, you will see a link that shows how to find the 3 by 3 determinant as well as a 2 by 2 determinant. Okay, so let's proceed. Now we have to find 3 by 3 determinants. To do that, the procedure is the same. Signs will alternate like that. So what we should have is this value which we have here, and let's just use brackets, because now we'll be forming 2 by 2 matrices. So the first value we're using is a 5. So everything except the row for 5 as well as the column for 5. I'm sure you get the idea now. So that will be 3, -2, 5, and 3. The next value is a -0. So everything except this row and this column. That should give us 2, 1, 5, 3. Okay, plus a 3, this 3 here. So everything except that row and that column, we should get 2, 3, 1, and -2. That's it. Now for this 3 by 3, whatever we do inside is will still multiply with a 0, so everything will just cancel out. So we won't even write it. We'll move to the next one, which is this one here. So we open our bracket. So again, signs will alternate. So the first value that we have is a 2. So everything except the row and column for 2 should be 2, 1, 5, 3. Minus 5, this 5 here. Everything except the row and column for 5, we have negative 1, 2, 5, and 3. And lastly, we have a positive 3. Everything except the row and column for that value, what we should get is this 2 by 2 matrix. Okay, so now remember we have one more 3 by 3 matrix, so I don't have enough space, so to just continue, let me bring it here. So we have a positive 6 outside, so 6 in bracket. So the alternate plus minus plus, what we have is a 2. The 2 by 2 formed will be 2, 3, 1, negative 2. The next value is a minus 5. The 2 by 2 formed will be this, okay? And lastly, we have a 0, of which everything will cancel out, but we'll just write the 2 by 2 formed, 2, 1, like that. Okay, so this is what we have. Now, let's simplify it from there. We have this 1 here, so of course 1 multiplying everything will just be everything as it is. So let's just open the bracket and say inside the bracket we have this 5. So the determinant of this 2 by 2 will be 9 plus 10. That's why I said you need to know how to find the determinant of a 2 by 2. So 9 plus 10, that's a 19. Here there's a 0, so everything will cancel. So plus this 3 here. So this will be negative 4 minus 3, which should give us negative 7. Okay, so we're done with the first bracket. If we go to the second bracket, remember we have a 4 outside for this one. So again we have a 2. 2 times 3, that's 6. 6 minus 5, that should give us a 1. Minus 5, this 5 here. The 2 by 2 formed will be negative 3 minus 10, which should give us a negative 18. Okay, lastly, what we have here is a plus 3. The 2 by 2 formed will be negative 1 minus 4, which should give us negative 5. Like that. Okay, close our bracket. Let's look at the last one now. So the last one, we have a 6 outside the bracket. We have 2. 2 multiplied by negative 2 is negative 4. Negative 4 minus 3, that should give us a negative 7. So 2 times negative 7 minus 5, this 5 here. This should give us a positive 2. Positive 2 minus 6 should give us a negative 4. 0 multiplies everything, and everything will just become 0. Okay, so this is what we have. Move on. So now let's try to simplify everything that we have. Okay. If we open this bracket, 95, or rather 95 is what we get when we multiply these two. So we say 95 minus 21, like that. Then inside this bracket, we have 2 minus 5 times 13 is 65. So that will give us negative 53, if I'm not mistaken. Then if we include this negative 15, the negative 15, the final answer we should get is a positive 52. So plus this 4 outside. Everything inside the bracket should give us a positive 52. Like that. Then lastly, this is negative 14 minus 20 minus positive, or rather plus positive 20, negative. Hence, everything from there will just give us a 6 inside the bracket. Like that. Okay. Then, simplifying this further, what we're going to get is 95 minus 21 should give us a 74. 52 times 4 should give us 208, and we add that to 36, like that. Okay, then when we add up all the values, what we should get is 318. So this means that the determinant of the matrix A, which is a 4 by 4, is equals to 318. We'll be looking at how to solve a simultaneous equation using a method known as the Cramer's rule. So the Cramer's rule is used to solve a 3 by 3, a 2 by 2, even a 4 by 4 matrix, and I'll show you how that is done in a few seconds. So the first thing you have to know is that you have to know how to determine the determinants of a 2 by 2 matrix, a 3 by 3 matrix, depending on which type of matrix you're looking at. So it's very important that you know how to find the determinant. Hence, I've dropped a link in the description just in case you don't know how to find the determinants. So go through that first, then you can come here and go through how to find the values of certain variables given simultaneous equations. Okay, so we have some examples. The first two examples are representing 2 by 2, two variables, and the second one is the second two examples are representing 3 by 3, three variables. So let's start with the 2 by 2s. Okay, so here's our first example. So what we're going to do is we're going to form a matrix. This matrix will of course be, the first one will be a 2 by 2, which will be, we'll have 3 there, 2, there we have 2, there 3. Now these matrices, this matrix that I've formed rather, is just formed by the coefficients, the 3, the 2, which is that one, the 2, the 3, which is that one, like that. Then I'm going to do this. This whole thing is equals to whatever we have here, which is 3 and 7. Okay, so the first thing we're going to do is we're going to find the determinant of this matrix. Now the determinant of this matrix, I'm going to call it D. So D will be given by the product of the major diagonal minus the product of the minor diagonal. Hence, the determinant will be 9 minus 4. That is this times that, which is 9, that times that, which is 4. We subtract the 2. Hence, our determinant in this case is 5. So we have found the value of D to be 5. Okay. Let's look at what else we need. So the next thing we're going to do is we're going to create the next matrix. Now the next matrix we're going to create will look like this. These values that you see here, this matrix, the 2 by 1 matrix, which has a 3 and a 7, since we want to find the value of x, the value of x, the determinant of the value of x will be dx. So what you're going to do is, you're going to create another matrix, which will look like this. From this matrix, the 2 by 2 that we have here, repeat the values of y as they are. But for the values of x, instead of writing the 3 and the 2, since we're finding the determinant for the x values, what you're going to replace it with is these two values that you have here, which is a 3 and a 7. Now, this will also work in the same way when you want to find the value for dy. So you will have the values of x will be maintained, which is 3 and the 2, but it's the values of y, or the coefficients of y, which will be replaced by this, which is a 3 and a 7, like that. So I hope it's making sense. So applying that concept, the next thing now what we're going to do is we're going to find the determinant. So this determinant is dx. So the determinant dx will be found by 3 times 3, which is a 9, minus 7 times 2, which is 14. So dx will be equals to negative 5, like that. We're going to move on to this one here as well, applying the same thing. So this is dy. So this one is dx because we substituted the coefficients of x with whatever we have on this side. This one is dy because we substituted the values of the coefficients of y with whatever we have on this side of the matrices that we formed there. So dy will will be equals to 3 times 7, which is 21, minus 2 times 3, which is 6. Hence, dy is equals to 5. Like that. So now that we have the three determinants, let's see how we can find the values of x and y. So finding the values of x and y, this is the easy part. The difficult part is finding the determinants. So to find the value of x, the value of x will simply be given by dx over d, just d. So to find the value of x, our dx, we found -5, and our d, remember our d was 5, so subtracting the two, the value of x is -1. To find the value of y, we're going to say dy, y is equals to dy over d. Now our dy in this case is just 5, and our d is also 5, like that. So meaning that the value of y is 1. So that's our solution set. X is equals to 1 and y is equals to, so x is -1 and y is equals to 1. Just like that. So let's do the next example as well. So for this example, I would urge you to pause the video, try it out, just like we did in the previous example, then see if you get whatever I'm going to find as well. Okay, so assuming that you just did that, so let's go ahead and solve it now. So we form the matrix. The matrix formed in this case will be 5, 7, -2, and 6. And on this side, we'll have the matrix 6, -4. Like that. So the first thing we're going to find is d. Now remember, d is found by the determinant of this matrix that we have here. So d will be equals to 5 times 6, which is 30, minus 2 times, -2 times 7 should give us -14. So the value of d will be 30 plus 14, hence d is equals to 44, like that. So we found the value of d. Let's find the value of dx. So we're going to rewrite the matrix. So the matrix will be, for the values of x, we shall replace them with these values that we have here, which is 16 and -4, like that. Then we write the values of y as they are, which is -2 and 6. So this will give us dx. So dx will be equals to, so let's find the determinant of dx. 16 times 6 should give us 96, minus -4 times -2 is +8, like that. So the value of dx will be equals to 88. So the value of dx is simply 88. Let's form the next matrix for dy. So for dy, we maintain the coefficients of x, which is 5 and 7. But for the coefficients of y, we shall replace them with 16 and -4. So here we have 16 and -4, like that. Then dy will be equals to, so if we multiply 5 and 4, so 5 times 4, what we get is -20, minus, if we multiply 16 and 7, we simply get 112. So that 112, -20 minus 112 should give us dy being equals to -132, like that. So this is the easy part, or rather, this is the difficult part. The easy part is just finding the values of x and y. So x is equals to dx over d. So our dx, remember our dx is 88, our d is 44. So the value of x is simply 2. The value of y will be given by dy over d. The value of dy is simply this one here, which is negative 1, 3, 2, and the value of d is 44. If we subtract the 2, or divide rather, we get negative 3. So that's our solution set. The value of x is simply 2, while the value of y is negative 3. Okay, so now let's quickly look at how to find determinants of a 3 by 3 matrix using the same approach. Okay, so finding the determinants of a 3 by 3 is a bit lengthy, but I'm sure we can do it. So let's go ahead. So let's create the 3 by 3 matrix. So the 3 by 3 matrix will look like this. We have 3, negative 2, 1, negative 2, we have a 2 there, and a 2. Here we have 8, 1, and negative 3. What we have this side is simply 9, 3, and 8. Okay, so we're going to find the determinant of this matrix, and that determinant that we'll be finding will be known as our D, of course. So let me form the 3 matrices that we are supposed to find that will guide us into the whole process. So the first thing we're going to look at will be dx. Now remember, dx, this is when we have to replace the coefficients of x with these values that we have here. So the coefficient of x in this case will become 9, 3, and 8. Then everything else as it is. So we have a negative 2 there. Here we have a 2. Here we have a 2 again. So 8, 1, negative 3. Okay. The next thing we're going to look at is dy. So dy, the matrix formed will be, we maintain the coefficients for x, which is 3, negative 2, 1. For y, the coefficients for y, which are these ones that we have here, we're going to substitute them with these, which is 9, 3, and 8, like that. The next thing we're going to look at is, of course, the coefficients for z, which we just maintain as they are. So 8, 1, negative 3. Then lastly, the matrix dz. So the matrix dz will be 3, negative 2, 1, negative 2, 2, 2. And lastly, we substitute the coefficients for z with 9, 3, and 8. Like that. So the determinants that will come from these 3 matrices, this is what we get as our dx, dy, and our dz. But before all this, remember, we first have to find the value of d. So let's find the determinant d. So to find the determinant d, like I said, you need to know how to find the determinant of a 3 by 3. So we can set this to be our positive. This is our negative. That is our positive, like that. Then we get the coefficients in the first row. So the first one is a 3. We create a 2 by 2, which will be 2, 2, 1, negative 3, like that. So where are these values coming from? If we're getting this 3 that you see here, then we're actually forming a 2 by 2 matrix, which is formed by everything except that value and everything except that row and this column. So this 2 by 2 matrix, which has remained here, is the one that we write here. The next value we're going to go to is a 2. But remember, this 2 has a negative, so it becomes a positive 2. So what will be the 2 by 2 formed? Everything except its row and everything except its column. So the remaining values will be negative 2, 1, 1, and negative 3. Like that. Then lastly, plus 8. The 2 by 2 formed is everything except this and this, like that. So the 2 by 2 formed will be negative 2, 2, 1, and 2. Okay. From there now, let's find the determinants of these 2 by 2 matrices that we formed. So we have the 3 there. 2 times negative 3 is negative 6. 2 times 1 is 2. Plus 2. Negative 2 times negative 3 is simply positive 6. Then 1 times 1 is 1, like that, plus 8. So negative 2 times 2 is negative 4. 1 times 2, of course, is simply 2. So let's simplify. Simplifying this, what we're going to get will be d is equals to 3 negative 8 plus 2 times 5 plus 8 times negative 6, like that. Let's proceed and find the value of d. So d will be equals to negative 24 plus 10 minus 48, like that. So it's very easy, and you avoid mistakes if you, of course, do it step by step. So negative 24 plus 10 minus 48. What we get is simply the value of d is equals to negative 62. Okay, so we have the value of d. So the next thing that we need to find is the value of dx, the value of dy, as well as the value of dz. So what we're going to do is, I'll finish up this question, but for the next question, I'll just give you the values of the determinants, and I'll request you to at least go through so that you find exactly what I'll find as well. So let's go ahead and find the three other determinants. So let's start with dx. So we're going to do exactly what we did in the previous determinant. So this is a plus, this is a minus, this is a plus. That. Then the next step will be to list down everything that we have. So we have 9. This dx. We have 9. The 2 by 2 formed will be 2, 1, 2, negative 3. Then minus, so again there's a negative there, hence it will become a positive. The 2 by 2 form this time around will be 3, 8, 1, and negative 3, like that. And lastly we have 8. So 8, the 2 by 2 form will be 3, 8, 2, and 2. Okay, so now it's just a matter of finding the determinants of the 2 by 2s. So this should give us, we still have a 9 there, so that times that is negative 6 minus 2, then plus 2, 2 by 2 will be negative 9 minus 8, and lastly we have 8, this will give us 6 minus 16, like that. So the next thing we'll have will be 9 multiplied by negative 8 plus a 2. Then here we'll have negative 17 plus 8 multiplied by negative 10, like that. Okay, so if we move on, this will give us negative 7, 2 plus, so this and this will give us negative 34, like that. Then lastly, that should give us negative 80. So adding everything together should give us negative 186. So this is the value of dx. So we'll come and review everything. So let's go ahead and find the value of dy. So the matrix for dy is this one that we have here. So let's find the determinant as well. So dy will be equals to, so applying the same concept where we say plus minus plus. So dy is equals to 3. The 2 by 2 formed will be 3, 8, 1, negative 3, minus 9. The 2 by 2 formed will be negative 2, 1, 1, negative 3. And lastly, we have 8. And the 2 by 2 formed will be negative 2, 3, 1, and 8. So that's what we have. Okay, so the next thing will be 3. The determinant there will give us negative 9 minus 8 minus 9. This will give us positive 6 minus 1, then plus 8. This will give us negative 16 minus 3, like that. So this will reduce to 3. This is negative 17 minus 9 multiplied by 5, so 5 plus 8 multiplied by 19. Okay, so 17 multiplied by 3 should give us 51 negative minus 45. Then 19 by 8 should give us a negative 152. So if we put everything together, so 152 plus 45 plus 51, we are finding a negative 248. So this is the value of dy. Okay, so let's do the last part now, which is finding the value of dx. So this is the matrix that was formed by dz, sorry, not dx. Same concept. This would be plus, minus, plus. Then from there, the next thing we're going to do is we're going to say dz is equals to 3. 2 by 2 formed is 2, 2, 3, 8, like that, plus negative, negative, 2, like that. So this is negative 2, 1 there, 3 there, 8 there. The next part will be plus 9. The 2 by 2 form is negative 2, 2, 1, and 2. So dz will be equals to 3. This will give us 16 minus 6 plus 2. This will give us negative 16 minus 3 plus 9. Then this will give us negative 4 minus 2. So our dz will become 3 multiplied by 10 plus 2 multiplied by negative 19 plus 9 multiplied by negative 6. Okay, so this of course will give us 30 minus, so 19 and 2 is 38, and then minus again, so we know that 9 times 6 is negative 54 in this case. So putting everything together, which is 30 minus 38 minus 54, what we get is simply dz is equals to negative 62. Okay, so what we're going to do is we're going to review everything that we have found so we find the values of x, y, and z. So these are all the determinants that we've accumulated. So to find the value of x, x will be given by dx over d. Our dx is negative 186. Our d is 62. So the value of x is simply negative 3. Y is equals to dy is negative 2. Sorry, let's write the formula. dy over d. So our dy is 248 over 62. So we get a negative 4. And z is dz over d. The value of z, or dz rather, is negative 62 over 62, meaning that what we get here is simply negative 1. So our solution set in this case will be x is equals to negative 3, y is equals to negative 4, and z is equals to negative 1. Okay. So with me, I have this question here. So what I would like you to do is just try it out. what I'll do is I'll present my d, dy, dz, and dx. Then we'll find the values of x, y, z. So go ahead, try it out. Then you compare with the values that I'll be giving you. Okay, so here are my determinants. The d I found 2, meaning that the value of x equals to dx over d. My value of dx was 14 over d, which is 2, so the value of x is 7. Y, my dy was negative, so dy over d was negative 6 over 2, so the value of y is negative 3. And lastly, z, dz over d, the value of dz was negative 8 over 2, hence we get negative 4. So that's my solution set. X is 7, y is negative 3, and lastly z is negative 4. So I hope you got it correct. In case you have a question, please feel free to ask in the comments. Thank you very much.